I love having these CTO conversations. We have the CTO and founder of Clumio, now the CTO of Commvault's cloud native division, Woon Jung, right? Yep. Welcome to the CTO Advisor, CTO Dose. The team reached out to me to record this sponsored content to talk about DynamoDB and why should I even as a developer in the Agentic AI setup be worried about backing up DynamoDB? Can you walk us through why that's even a thing? What's the problem?
Yeah, well, first of all, the agentic AI changes the behavior of the applications, right? The applications are more autonomous, adaptive, and they can take actions without human intervention. However, what it doesn't change is that it is only as good as the input data. In other words, it's really garbage in, garbage out, okay? But what we should think about and is about the the amplification factor. This agentic AI allows you to implement amazing things and do things really, really fast, which amplifies the value. But at the same time, it also amplifies the potential accident. Small accidents, these LLMs could actually very quickly make it into a big accident. So DynamoDB, which stores things like customer data, states, and even things like LLM intermediate states, corrupting that table could actually have very catastrophic consequences for the enterprise.
So I have first-hand experience with this. I've been doing a lot of agentic AI based application development, and I use Git as my workflow. And I'm accustomed to using Git every time I make a major or even a minor change. It's simple to just write that change to my Git repository. Learn the hard way. When you introduce an agentic workflow into your development, the agent can go rogue. And it dropped the table from my database. And when I challenged it on it, it said, oh yeah, sorry, made a critical mistake in dropping data that wasn't backed up.
Okay.
So that wasn't part of the workflow. Talk to me about the gap in the existing workflow that you're seeing.
Yeah. So to say that DynamoDB does not have versioning at all, it's a little incorrect. So DynamoDB, which let's say is this table here, has a feature called PITR. So think of PITR be more of a transactional wall, so that all the updates that happens, it also gets not only updated into the table, but into this log here. So then as a user, you can leverage that log to create a brand new table of at a specific point in time. Let's say you made an accident yesterday at 3 p.m. and you want to go back. The combination of the table and then PITR allows you to create a brand new table as of 3 p.m. yesterday, right? This is 3 p.m. Sure, this is going to be more of a rudimentary versioning,
Right.
very similar to what you're talking about. It lacks some of the functionality, but it is a good starting point.
Right. So where does Clumio come in? What advantages am I getting on top of what this pitter process I had with DynamoDB?
Yeah, so there's a couple of things. Let's start with the very first one is air gap, being able to create a discrete copy of your table.
Mhm.
So like I said, you could use that pitter table to create new tables,
Right.
correct? But this is within all of your tenancy. This whole thing is within your own tenancy, meaning if a malicious attacker were to have access to that table or to this whole account, guess what? It could
I can do either race or corrupt the table. I can attack your backup.
yeah, that too. And then it's as simple as disabling pitter, in which case you could actually end up losing all of that pitter. At that point, you don't have the capability to go back in time.
Okay.
So then what you want to do to protect the data is to create a separate copy in a different entity altogether to actually create a backup, right? So that allows you to do, you would have an independent copy.
So when I back up, am I backing up the entire database, including the logs and pitters? Or am I having an additional level of redundancy? Or am I just backing up just the database itself?
Yeah, so that's a great question. So, first of all, yes, we'll back up. Basically, this will be Clumio. and then this will be your AWS tenancy, correct? And then when we back up, we'll back up the entire table, but we'll also do what's called an incremental backup, because this table is not a static table, but you're continuously changing, right? So we'll actually go ahead and do that. Now, coming back to the air gap again, the benefit of this approach is that even if your account here, which is your tenancy, gets compromised, you have that second table that you can actually restore from.
So I want to make sure I'm clear on this. This is happening in my AWS VPC.
Yeah, that's yours.
With everything with all of my access control and my attack surface is here. I'm completely copying this over to a completely different environment that doesn't have the same control plane as my AWS control plane.
Yep, that is correct. So then anything that happens here will not impact your backup data on this side at all.
So this is good backup hygiene. Yeah, I'm accustomed to this. Let's bring the discussion back to agentic AI. What are some of the practical agentic AI use cases that we're seeing?
So before we go there, so let me just kind of finish these other questions about what, Clumio brings to the picture, right? This is first, which is kind of, we provide you that air gap copy, right? The other thing that I think you mentioned was, is this a single copy? How is this done incrementally, right? So like I said, changes are happening, continuously happens here. Then you have to transfer that, right? Because let's say the first backup was, 1 p.m. But if somebody made a bunch of changes in between 1 p.m. and let's say,
right, I mean that's my recovery point. It was what we up
to capture all of those things. So what we do is we capture what's called incremental backups, right? So let's say the initial table was 1 terabyte in size, but then every hour, it wouldn't change much. You would change the whole entire terabyte. Let's say, 100 megabyte changes every hour, and we'll actually capture that incremental backups. So one of the differentiations that we have as compared to the AWS backup with the native solution is that AWS backup allows you to do something similar. However, the challenge there is that all of the backup happens to be a full backup. So what you're forced to do is, let's say hypothetically, our requirement is to keep 7 copies, 1 copy per day, because you want to go back to, let's say, Monday or Tuesday or whatever. So you're keeping the last 7 days. What that really means is that you're actually retaining 7 full copies, which means that you're not retaining 1 terabyte and
multiplied over the number of copies that I have.
Yeah, so you have to multiply the 7 terabyte, the 1 terabyte multiplied by the 7 copies, rather than having 1 terabyte and 7 incrementals, which are much, much smaller.
And from a practical perspective, how does that impact recovery?
Well, recovery, from a recovery standpoint, is not, it doesn't impact it at all. But one thing that this will drive TCO. Right. You're not paying 7 terabytes, but you're paying 1 terabyte plus, let's say, 700 megabytes.
Okay.
Which is drastically lower than the 7 terabytes, right? So that's TCO.
I actually did not know that about AWS backup, that it did a full backup every time it does a backup.
Yep, that's what it does. And then now you talked about the recovery modality, which is actually, again, a very important concept here. Now, another gap that the built-in native solutions have is the different flexibility when it comes to the restore mode. Like I said before, you could always restore a full table, as a new full table, but it doesn't allow you to restore partially. Like you can't restore, like I think you also talked about some of the accidents. Right. Let's just go through that accident or that experience, that thought exercise.
Right.
To go through and just kind of outline the differences.
Mm-hmm.
Let's say that we have this table and this is your production table.
Okay.
And then DynamoDB organizes data in what's called partitions, right? So let's say I have, in this case, 6 partitions.
Okay.
And then this stores customer data. Partition 0 has data related to user 0, partition 1, user 1, and so forth, all the way to user 5, and partition 5 that stores data for user 5.
Gotcha.
Okay. So then let's say that some, agentic AI application, something went rogue. There was an accident. And then essentially a bad software or something bad happens on this partition at 2 p.m. And let's say something bad happened here at 5 p.m. Okay.
Yeah, and in the interim, I have all of these legit transactions between here and here.
Yeah, so customer 0, 2, 3, 4, they're perfectly fine. They're all happy. But customer 1 or user 1 and user 5, they got impacted, right? At different points in time. This one at 2 p.m. and that one at 5 p.m. So what we need to do is to actually go ahead and patch these things here. Patch the user 1 and patch the user 5. It's very similar to your Git example that you gave me. Like, you made a mistake in a single file. You want to revert that one file, not your entire source.
Or I can have my agentic AI or my developer look at a specific block of code and recover that specific block of code. Because it's a manual process, but still I can do that.
But this is the problem statement that we have to go and fix.
So I want to make sure we drill into this because I assumed AWS Backup takes care of this level in the traditional infrastructure. We just call it brick level backup. That individual records or individual partitions we can recover. There's different recovery points for within that. So you're saying if the end result is that if this corruption happened, my only real option with the AWS solution is to recover the entire.
Yeah. So then, like, if
Data set and then reconcile between.
there's a couple of options, right? They say, put Clumio aside for a moment. So what are your options when you're faced with this type of accident here? So number one is that, okay, well, let's just go ahead and do a full restore because that's what I could do. Right. So we said this happened at 2 p.m. So then what I'm going to do is, maybe I'll erase this. Then let's say 2 p.m. Okay. So I'm going to restore the entire thing on 2 p.m.
Right.
Okay. And these are all the 6 partitions. Now, you could actually change the applications to directly use this table, right? And get rid of this old one that re-erupted. Is that functional? Yes. Well, you could argue that it's functional, but then what's the problem with this? The problem with this is that user 0, 2, 3, and 4, they were perfectly happy, but you are taking them all back to 2 p.m. pointlessly.
Right.
Just to fix that one customer.
Or I have some manual process, I could automate it, but I have some process that reconciles the two partitions, but that again adds complexity.
Then what do you need to do? Like exactly like you said, we have to take partition 1 from this new fully restored table. We'll have to do a copy. Okay. And then what we need to do is we need to do yet another full restore because remember that the accident happened at different points in time, right?
Right.
So then this one, it's at 5 p.m. And then we would have to take partition 5, which is this one here, and copy it here. So 2 full restores, 2 copies. You have to cherry pick partition 5. You have to cherry pick partition 1. And once this is all done, you have to go ahead and make sure and delete all of these tables. And then you are able to recover all this.
Yeah, I'm already getting into an operations nightmare. I've done enough disaster recovery testing to know if you don't remember to go back and delete the temporary partitions, somehow this becomes live production and that you're in a world of trouble. So now, talk to me about how Clumio changes the operational motion of doing a recovery based on kind of this two-point scenario.
Okay, got it. So first one, just to recap, is the fact that this is an air gap copy. The fact that anything that happens here, nothing will happen to your backup. So it's really air gap. And related to air gap, because we do these incremental backups, is really reduces your TCO. Right. And then the second thing is we still allow you to do PITR, which is, we allow you to pick any point in time. Right. It could be 2, 5, or, whatever. Up to the second gallery, middle of things. So PITR. We allow you to do what's called the granular restore. What that means is that, I can allow you to restore a single partition, a couple of partitions, or even a single item. So let's just call it, granular. Granular restore. And then lastly, we implement what's called either out of place or in place restore. In out of place restore. So it's a combination of these 3. So let's combine these things. Let's say these features to go ahead and fix what happened here. No, now you as a user, if you had this MX accident, but you were protecting it using Clumio, all you need to do is really 2 API calls. You tell me, I want to restore partition 1, which is this one here, as of 2 p.m.
Right.
from here to the in place. What's called is not an out of place, but will allow you to in place restore. So then the first API is going to say, take this, which is, the partition number 1, and restore it directly into it. So it's basically partition key :1 as of 2 p.m. One API call. And then the second API call will say partition key :5 as of 5 p.m. So there's no need for you to this full restores, to copy things over, to delete things over. It's just 2 API calls, and then you are able to patch it and go.
So, couple of questions. First off, obviously, this is an immense capability. I don't have to restore to a offline copy and then make my changes and come back and recover straight to production if I want to. I get the granularity of at the partition level, which is also great. But users are going to automatically think, okay, what am I sacrificing? Am I sacrificing any consistency in the database? Are there any sacrifices? How much can I trust this process if I want to restore to production?
No, in terms of sacrifices, honestly, I don't think it's actually hard for me to come up with any downside or sacrifice.
Right.
It's actually solves both the TCO, the fact that it's air gap, and these are all great features. I don't think there's main concerns or sacrifices that you would have to make.
I'm not going to push back hard because I thought this is how it should have worked from the beginning. I'm sure you run into that scenario with customers all the time.
I would say that maybe one last thing, if I really have to come up with something, is that really PITR is a built-in functionality of the DynamoDB table. And depending what you want to do, PITR is also a good functionality. Maybe for the use cases where this is good enough, where an in-account protection is just good enough and it gets the job done, that's where you just end the day. That's it.
So there's this obvious question that whenever I use a service that is outside of the AWS container, what is my developer experience? What does this look like to the developer?
Oh, to the developer. Is technically developer or the SRE organization. The way that you onboard Clumio is through either CloudFormation template, Terraform, or APIs. So then what we do is, obviously, when we're extracting and restoring, backing up and restoring data, we rely on what's called an IAM role. We need an IAM role that has to be in the customer's tenancy. So I say, this is your IAM role that has to be created, which has a policy attached to it. It is the policy that allows us to either back up or restore data from the source account back into this Clumio account here. Now, from a developer standpoint, all you really need to do is to actually install a CloudFormation template or a Terraform to actually go ahead and install that IAM role. Once that is in place, you effectively onboarded Clumio to your AWS account.
Right.
The next thing that you need to do is to go ahead and start applying policies.
So this isn't impacting my actual day-to-day development and development experience. I am just oversimplifying, flipping a switch on my to now Clumio to have access to my from IAM to my AWS container.
Yeah. So on a day-to-day basis, as a developer, it's something that you don't have to worry about. It is that the data is protected. So all you need to do is just go on writing, the things that matter, the business logic, the application that is important to the business, and then the backup is just basically taken care of.
So last question for our IT decision makers: what's 2 or 3 major points that they should be asking when it comes to DynamoDB, specifically to backup and data protection?
So one thing is, it's really about making a decision based on the type of data. So you have to know, you have 100 tables, you have to make a call. What tables are important and what level of protection do you need to do, right? Is PITR good enough? Or maybe there's a requirement to create a second copy. So then you would have to make that decision and create a solid protection plan, right? As a goal, that you have to go. And then once you have that, let's say out of those 100 tables, we did identify that 50 of them require a second copy. Okay, great. Once you do that, there's different tools that you can actually use. AWS has some that are native from AWS Backup. Clumio, of course, we have our own. Then you have to start asking the questions about, TCO. Yes, I can create a discrete copy. What does it mean to the TCO? Am I creating 7 full copies or 30 full copies? Or am I actually creating one full and many incrementals, which, TCO. Third thing is that we talked about all of this exercise. It's not all about backup. You have to think about, how do you restore it back? When it's time to restore, because accidents are always a lot more complex, right? It's not as simple as, hey, this whole table goes away, therefore I'm going to replace it. It's never that way. It's always partitions, got corrupted and stuff like that. In which case you're resorting to something very complex for you to do the restore. So it's not like they will come and give you basic functionality, but you as a user, you would have to write all of this automation yourself. Then think about that. Like, when it is time to restore, and these are not like the simple, hey, in simple accident, because again, accidents are complex. Think about how you're going to restore it.
All right. Well, I hope you enjoyed this exceptional example of where AWS is and AWS ISV infrastructure comes into play, and these partners help solve a lot of the operational gap. You want to learn more about the CTO Advisor? You can find us on the web, thectoadvisor.com. Obviously, Clumio is now part of Commvault. We can find them on the web at commvault.com. Thanks for tuning in.